Good morning, students. So let's start our class. I hope all of you are able to view the screen very clearly.
Yes.
Okay, great. So first, what we will discuss any doubts if you have in those two DPPs what I sent yesterday. Uh,
Yes.
if you have any DPPs, please do let me know which DPP, which question you have, doubt, dear students.
So I have doubt in question 10, DPP5.
Okay, sure. Let me open up.
Yes.
Okay, so let me share the relevant website KonarClasses.com. All of you are able to view the website, dear students.
Yes.
Okay, great. So then let me go to the particular DPP. Which DPP, dear students? Mohor, which one you said?
DPP5.
DPP 5, question number 10. Correct.
Yes.
Okay. So find the sum of the in terms of the sequence 8, 8, 8, 8, 8, 8, 8, 8, 8, 8. Very good question. Good classical question. How many of you are able to do it, dear students? Anyone has?
I got stuck after a certain step.
Achha, you got stuck after certain steps. Okay. So let's discuss. Okay. So apparently, dear students, if you see, apparently it looks like this doesn't belongs to in neither AP nor GP. Correct or not?
Yeah.
Okay. Divansu, Sagnik, you able to do this thing? Disha? Hello?
Oh, sir.
No? Okay. Okay. So let me share the digital screen. Yeah. So as you see, just confirm once that you are able to view the digital board, right?
Yes.
Okay. So what is here? It is 8, 8 plus 8, 8, 8, 8, 8, 8, 8, 8, like that. So we need to find that Sn. So let's assume Sn be the sum up to the first n terms. Okay. That means what? Sn is equal to 8 plus 8, 8 plus 8, 8, 8 plus up to, in that way it goes up to n terms. Correct or not?
Yes.
And it is absolutely fine that you have not you are not able to do it based on the fundamental understanding of arithmetic progression, geometric progression, because there is a particular technique to solve this kind of questions. Okay. So what we are going to do, so we are just going to rewrite the same thing in little different forms, and you also do along with me, dear students. Okay. So what I'm doing, I'm taking 8 by 9 common. To make more simple, let me take first 8 common. If I take 8 common, then what I'm going to get, dear students? 1 plus 1, 1 plus 1, 1, 1. Correct or not?
Yes.
In that way, up to n terms.
Yeah.
After that, what we're doing, dear students, I am taking 1 by 9 common. Then to adjust, I need to multiply 9 in the inside. Correct or not?
Yes.
Up to n terms. Correct or
Yeah.
not?
Yes. Okay.
So now this, what you see here inside that, 99999. So 9 I can write is the 10 minus 1. Correct or not?
Yes.
99 I can write 100 minus 1.
Yes.
999 I can write 1000 minus 1. Correct or not? And
Okay.
in that way, it goes up to 10 terms.
Yeah.
Correct or not?
Yes.
Then, after that, what you are doing, dear students, I am writing 8 by 9 as it is. Then this 10, 100, 1000, that I am actually clubbing together. That means what I am getting 10 plus 100 plus 1000. This I am actually clubbing together, and that is equal to up to n terms. Correct now?
Yeah.
Then minus, what happened is that minus 1, minus 1, minus 1 up to n terms.
Minus
That means as if it is minus, if we take common 1 plus 1 plus 1, this goes up to n terms.
yes.
Correct or not, dear students?
Yes.
So from here what we are getting 8 by 9. So the 10, 100, 1000, I hope now you got it. This is in geometric progression. Correct or not?
Yes.
So as if we can write here it is as it is 10 plus 10 square plus 10 to the power 3. Correct, no?
Yeah.
In that way, up to you get n terms. In fact, we can find what is the nth term. Can you please tell me, someone, what is the nth term? It will be 10 to the power n.
Yeah.
First term is 10, means 10 to the power 1. Second term is 10 to the power 2. Third term is 10 to the power 3. So in that way, nth term should be 10 to the power n.
And
Correct or not? And minus, can you please tell me what will be the value of this thing? 1 plus 1 plus 1 up to n terms. It will be simply n, as if you are adding 1 n times.
yeah.
Correct or not?
Yes.
So then it is quite simple. After that, if you recall
Yes.
the formula, what we learned yesterday,
Yes.
that sum up to the first in terms of an geometric progression. In this case, we need to apply the formula where r is greater than 1.
Yeah.
Correct or not?
Yes.
Or, we can say, mm, yeah, obviously r is greater than 1. So if you recall that it should be a into r to the power n minus 1. That means 10 to the power n minus 1. Here first term is also 10 and common ratio is also 10.
Yeah.
Divided by 10 minus 1. Correct or not?
Yes.
Minus n. So now that is the answer. Any doubt, dear students? Any simplest doubt in understanding this one? Okay. Very classical question, very likely to come in some of your exams, either in your board examination or in any of your school examination or in your entrance examination. Very likely to come. So whenever you will get this kind of stuff, always, approach should be like this. In fact, I thank you very much, Mohor, for bringing this question. And always open up. That I always appreciate. Next question, anything you have, dear students? Srijita, if you have any question, never hesitate. Disha, Dibyansu, Gurman, Tagnik. If you do not have any questions, any other doubt from these two DPPs, what I gave yesterday, then what I can do, I can resume the discussion where I left yesterday.
Yes.
Okay, all right then. Okay. Now, if you recall, dear students, so in the last class we discussed about the nth term, how to find the nth term of a geometric progression, followed by sum up to the first n terms of a geometric progression, and then we took a special case of that sum, in which case r is less than 1, or especially to say when r is in between -1 to +1 and it is an infinite GP. Correct, no, dear students?
Yes.
Okay, and we discussed that how to deal with this kind of situation, and it is quite simple. Always remember that will come in your physics numericals also, that sum of an infinite geometric progression, sum of an, I repeat, the sum of an infinite geometric progression in which the common ratio is less than 1. And that is very simple. That is equal to a by 1 minus r, where a is the first term and r is the common ratio. So eventually, let me ask you one question: is that what will happen? It is a infinite geometric series with common ratio greater than 1. What will be that sum? Could you please give me some idea about this thing? Okay, quite simple answer. That will be infinite.
Maybe that comes from
Exactly. I mean, that is not possible to compute because common ratio is increasing. Okay, geometric progression, right? So what is that? Think about one classical case. Take the first term as 2 and common ratio as 3. Then what will be the series? 2, 2 comma 3, 2 comma 3 square, 2 comma 3 cube, and then see, you see, as you go with the different terms, it is actually increasing, isn't it?
Yes.
Now, as it is increasing, is very difficult. Correct? No. Very difficult means very. It's not difficult as long as the sum is constant. It is infinite. As simple as that. What will be the 1,000 terms? Very big term, no?
Yeah.
2 into 3 power 999. That is a very huge term. Now you need to add all these terms, right?
Yes.
So that is a quite as a side discussion I just asked. So that is not our point. That only point is that it is an infinite geometric series in which the common ratio is less than 1. Means, or very specifically to say, common ratio is between -1 to +1. Now, dear students, so let's start our discussion with the geometric mean. If you recall, when we discussed about arithmetic progression, we discussed about arithmetic mean, if you recall. Correct, no? As I said that, what is, if you take two numbers, A and B, what is their arithmetic mean? It is A plus B by 2, correct, no, dear students? Correct?
Yes.
So, in geometric mean, what happens is that, so you take two numbers, A and B, okay, their geometric mean, as you see, dear students, as it is, as you see in the screen, it is equal to, square root of A into B. Correct. That is the geometric mean. That square root of A into B, the positive square root, by the way. Correct? Clear or not clear? So, by the way, any two numbers are always, in if any two numbers are given, they are always in geometric progression, as we discussed. Only two terms. They are also in arithmetic progression also. Correct or not?
Yes.
So, what happened is that suppose you have, two numbers given in A and B. Then these two numbers are always in arithmetic progression, also geometric progression also. Now let us focus only on geometric progression because we are discussing geometric progression now. Now what happened, dear students, if we insert in between a number called square root of A and B, then we have three numbers. First number is A, second number is square root of A into B, and third number is B. Correct, na, dear students? Now these three numbers are in geometric progression. You see, the ratio between square root of AB and A is equal to the ratio between b and square root of ab. Correct or not?
Yes.
So in that way, what happened is that if you have two numbers, a and b, in between you can add in geometric mean, correct or not?
Yes.
So this is G1, G2, G3. Recall, dear students? In that way it goes, and finally it become actually Gn, correct or not?
Yes.
In between, what happened is that in between A and B, we have inserted n geometric means. Then the point is that what will be the kth geometric mean? Correct? If you recall, when we discussed about the arithmetic, mean, when we are inserting n arithmetic means, there also we discussed that how to find it out. Not only formula, we also found that how to find it out. Correct, no? So
Yes.
here the formula, absolutely standalone formula is given. Gk equal to a into b by a power k by n plus 1. That will be the kth geometric mean. Correct, no? G1, G2, G3, these are the subscript. Dear Sagnik, you recall that you asked a question on that on arithmetic mean. So in that way, also here you will get something called Gk. Correct, no? Here k is the subscript. That k is geometric mean. What is that kth geometric mean? That actually obtained from this formula. Because to find the geometric mean, only you have 4 items in your hand. First item is the A, second item is the B, third item is that how many geometric means you are inserting, that is the n, and the fourth one is that which geometric mean you are going to find out, that is k. Correct, dear students? All of you agree to me?
Yes.
This absolutely clear, this, sir? Gurman?
Yes.
Dear Gurman, absolutely clear?
Yes.
Okay. So we are going to, we can find out, how to, how Gk is equal to A into B by A power K by N plus 1. So the way to find out is that, first you see, we know as A is the first term and B is the, which is the term B, dear students? B is the term, if A, one thing you are pretty sure, na, that A, G1, G2, G3, Gk, Gn up to B, they all are in geometric progressions, correct or not?
Yes.
As they are in geometric progression, let us assume that in this geometric progression, the common ratio be R, correct, no, dear students? This is a geometric progression, correct or not?
Yes.
As this is a geometric progression, this is in GP. So geometric progression is, in short form, it is known as GP. So what is the B? B is nothing. B is a which term? Could you please tell me, dear students? In this geometric progression, A is the first term and let R be the common ratio. Let R be the common ratio. Let R be the common ratio. Now, what I'm asking, dear students, can you please tell me B is the which term of this GP?
Last.
Anyone? Yes, what answer you give, Mohit? Little louder, please.
I was saying the last term, but
Obviously, last term. Last term that you all know, but which term it is?
Is it n plus 2th?
Fantastic. Who is this, Sagnik? Appreciate.
Yes.
Yes, it is the n plus 2th term. How? You see, you have already inserted n geometric means. And before that, there is a term A. That means till Gn, you have n plus 1 terms. No?
yes.
Then B should be n plus 2th term. So it is the n plus 2th term. Dear students, these all are very important. If someone is not understanding, never hesitate. It is your responsibility to make your understanding rock solid. Okay. So never hesitate that, okay, what sir will mind, nothing like that. Okay. N plus 2th term of the GP. Correct or not? Now, n plus 2th term of the GP. So now we can apply that formula now. If you recall, in a geometric progression, if A is the first term and R is the common ratio, then the nth term is that A into R power n minus 1.
Yeah.
So here it should be what? B should be A into R to the power n plus 2 minus 1, that is n plus 1.
Yes.
Correct or not, dear students? So that we get the value of B. Now, what we need to find? We need to find the kth arithmetic mean, a geometric mean, sorry. So what will be GK? Now let's find GK. GK is the kth geometric mean of the kth geometric mean is nothing but the k plus 1th term in the given GP. Correct or not? All of you agree to me?
Yeah.
It is the k plus 1th term of the GP. Correct or not?
Yes.
Term of the GP. So this implies what? This implies GK is equal to k plus 1th term of the GP. Now, k plus 1th term, we know by this time that should be A into R power k.
Yes.
Correct or not, dear students?
Yes.
So all you need to find the value is that R. And for that, we can take help of this left-hand side equation. What is R to the power n plus 1, dear students? R to the power n plus 1 is equal to B by A.
Yeah.
Correct or not? So from here, we can find the value of R is equal to B by A power 1 by n plus 1.
Yeah.
Correct, no, dear students? And that value, we can apply it back here. So then what we are going to get? This implies GK is equal to A into R is what? B by A. Correct, no, dear students?
Yes.
B by A power 1 by n plus 1. Correct, no?
Yeah.
Let me write 1 properly. N plus 1 and whole power k. Correct, no?
Yes.
I'm just writing step by step so that there should not be any confusion. And that implies GK is equal to A into B by A power k by n plus 1. And that's what we have achieved here in the formula, if you recall. If you see, this is the formula, no, dear students?
Yes.
This is the formula that I initially wrote. Just please spend a couple of minutes in looking into it. Correct, no, dear students?
Yes.
Absolutely clear.
Yes.
Okay. Now what we are going to do is that a very important point I'm going to say you, dear students, very, very important point. Okay. Give a full concentration on this. If you recall that I said for any two numbers, if any two numbers is given to you, you can find their arithmetic means. Suppose two numbers given to you is that A and B. What is their arithmetic mean? That is AM is equal to what, dear students? A plus B by 2. And what is their geometric mean? Let's suppose GM is equal to square root of A into B. Always remember, that is the important point. Arithmetic mean is always greater than equal to geometric mean for any two numbers A and B. And I want to establish that formula. I am to establish the claim what I just made. Arithmetic mean is greater than equal to geometric mean. Correct, no? How? I'm going to show you. This is very, very important. You will get lot of questions in algebra for your entrance examinations where you need to apply this concept. You will get lot of questions in linear inequalities, what we will be discussing later, where you need to apply the concept that arithmetic mean is greater than equal to geometric mean. That concept you need to apply so many times. So hence this is the right time that I should establish this inequality. So, and establishing is very simple, dear students. Very simple in the sense, because whatever the mathematical, operations I will be doing, that we all know from 9th or 10th standard mathematics. So what is the arithmetic mean? Arithmetic mean is equal to, is nothing but 1 by 2 into a plus b. Correct, no, dear students? And that is equal to 1 by 2 into, what we can write is that a plus b, we are writing square root of a whole square. Not a big deal, no?
Yes.
Then b, we are writing square root of b whole square. Then what we are doing, dear students, I am introducing, a term called, minus 2 into square root of a into square root of b. And the same term I am adding 2 into square root of a into square root of b. Then it is fine, na?
Yes.
Why I am done so? That will discuss. That will understand in another few minutes. So arithmetic mean is equal to 1 by 2. So now let's focus on the first three terms. What is that? It is square root of a minus square root of b whole square, no, dear students?
Yes.
Square root of a minus square root of b whole square plus 2 into square root of a into square root of b. If you see, dear students, all these things, whatever I am doing, it is just, 9th or 10th standard mathematics, correct or not?
Yes.
And sometime to achieve our desired result, we need to, add something and subtract the same quantity, whatever I have done in the previous step. Then what happened is that, dear students, is that this implies arithmetic mean is equal to 1 by 2. Let me write 1 by 2 into square root of a minus square root of b whole square plus 1 by 2 into 2, that becomes square root of a into b. 1 by 2 and 2 got cancelled, na?
Yeah.
So then what we get, arithmetic mean is equal to 1 by 2 into square root of a minus square root of b whole square plus, what is the square root of a into b? That is geometric mean.
Yes.
So from here what we get, dear students, arithmetic mean am minus gm is equal to 1 by 2 into square root of a minus square root of b whole square. Correct, not, dear students? Now let us focus on the little bit of apply our common sense. What is a and b? A and b are real numbers, correct or not? So their difference would also be a real number, correct? That is
Yes.
square root of a minus square root of b. Now, if you take a square of that real number, definitely you will get a positive number, right?
Yeah.
So that means what? Am minus gm is always greater than equal to 0. Now, I'm just asking one question as well. If what I'm writing first. So arithmetic mean minus geometric mean is greater than equal to 0. Correct or not? Why I'm writing greater than equal to 0? Why I'm not writing greater than 0 or equal to 0? Equal to 0, so I cannot write directly because, obvious thing. But why I wrote when equality happens? When I wrote that arithmetic mean, if you see in the left hand side, arithmetic mean is greater than equal to geometric mean. What does it mean? It means is that either AM is greater than GM or AM is equal to GM. That means there will be some cases where you will find AM is equal to GM. What is that case? That case is, dear students, if you are not answering by now, that case arises when B is equal to A.
Yeah. Yes.
Clear or not clear?
Yes.
If B is equal to A, then right hand side equal to 0. So when I said that there are two numbers A and B, what is their arithmetic mean and geometric mean? At that time I didn't give any restriction, na, that B cannot be equal to A. B can be equal to A also. Correct, na?
Yes.
So in general we can say this thing. So what we can write, equality occurs when A is equal to B. Correct or not?
Yes.
So this is a very, very important relationship. I'm just repeating that word very, very couple of times because this is so important. Looks like it is very simple to establish, looks like it is so obvious, but point is not that. Point is that application of this, inequality, that arithmetic mean is greater than equal to geometric mean, application of this thing and the proper time in solving lots of algebra problem is the most important part. Okay. Now, just let me write it down in theory, whatever we just discussed, so that we can complete this and then we go to the next one. So I'm just writing, dear students. So from the note is that if AM and GM, be the arithmetic mean and geometric mean of given numbers A and B respectively, then AM is greater than equal to GM. The equality occurs in the above equation if A is equal to B. Correct, no, dear students?
Yes.
Now we are going to discuss little bit of interesting thing, and we have discussed similar thing for arithmetic mean. If you notice, dear students, just from the previous discussion, arithmetic means you need to choose, three consecutive terms of an arithmetic mean. Why you choose like those particular type pattern? Because generally in most of the problems, it has been given their sum is something like that. We have done one problem like that also earlier. No? There are three numbers in GP, their sum is such and such. So at that time, what we used to do, A minus D, A plus D, so that D get cancelled if we add all these three numbers.
Yeah.
In geometric progression, what happened, dear students, now, is that here also there are consecutive terms, but there generally it gives in the product. Whatever in an analogy, you see, analogy is the concept we use, is that in arithmetic progression, whatever you think about addition, in geometric progression, you can think in an analogical way, we can say it's a means of a multiplication. Okay. So, in a very light terms, I'm telling, okay, don't take it in absolute term, each and everything, but generally is that when you do, you'll understand why I'm saying so. If you need to choose three consecutive numbers of a GP, what you are going to do, dear student, if I ask you? You don't need to answer. If you do not know, that is perfectly fine because we are learning. So here it is. I'm just informing. After that, you can answer the next one. If you know the product, of three consecutive numbers of a GP, but you do not know the numbers, assume the numbers as A by R, A, AR. The first number is A by R, second number is A, and third number is AR. So as we know the product means what? Multiplication, dear students. But if you recall, with a similar situation in case of arithmetic progression, what was there? If you know the sum of three consecutive numbers of a AP, correct? Sum means plus. So what the sum you see in case of arithmetic progression, in case of geometric progression, that actually kind of product. So the thing is that if you know the product of three consecutive numbers of a GP, but you do not know the numbers, assume the numbers as A by R, A, and AR. Correct, not your students? Clear? Absolutely clear?
Yes.
Sagnik, Divansu, Gurman, Disha, Srijita, absolutely clear?
Yes.
Okay.
Yes, sir.
Okay, thank you very much. Okay, Srijita, clear? Disha?
Yes,
Okay,
sir.
great.
Yes, sir.
Okay, great. Now, you answer me that if there are four consecutive numbers, if you know the product of four consecutive numbers of a GP, but you do not know the numbers, what will be the numbers?
So would it be A by 3R, A by R, AR, and A by 3R, A3R?
Okay. Point is that, but those numbers are in GP. Dear Gurman, what the numbers you said, A by 3R, A by R, A, and A into 3R, are the numbers in GP? As the ratio of the consecutive terms are equal? I hope it is not. Or if it is, let me know. Dear Sagnik, what will be your answer if I ask you this question? If you need to choose 4 consecutive numbers of a GP, what numbers you can think of? Dear Dibansu, Mohor, Srijita, Disha, anyone can answer. Just apply your intuition. Little bit of intuition you need to apply. And you need to recall the way we have done is for arithmetic progression.
Be like A by R square, A by R, A and AR.
A by R square. Okay,
A
let's
by
do this
R.
thing. Let me write it down. Okay, what you are saying? You are saying that I'll delete it after writing A by R square.
A by R,
A by R.
A and AR.
A and AR. Now
No.
there is nothing wrong in choosing these numbers, but unfortunately, if you multiply all these numbers, then you will not get rid of R.
Yeah.
So that is why. So you will again land up with 2 unknowns in the product A and R. Correct or not?
Yes.
It will be a power 4 by R square. So as we are, our task is what? Just to reduce that unknowns to 1. Their mathematical problem. What is our target? Our target is to reduce as many as unknowns. Correct? Generic term anywhere.
Yes.
So in context of that, this is not the proper one. Sagnik, I was expecting an answer from you. Disha, I was expecting an answer from you.
So I also thought it would be A by R cubed, A by R.
A by R cube is different than A by R square. Mohor said A by R square. What you are saying?
A by R cube, A by R, AR and AR cube.
Correct. And you are the first one answering this one, right? So when you said I also, it is not also. Okay.
Oh, I thought Gurman said this.
Goodman said A into 3R, na, dear Goodman?
Yes.
You said A into 3R, na, dear Goodman? But here it is, as you see, all of you, please note it down. A by R cube, A by R, AR and AR cube. Now if you multiply, Mohor,
Yes.
if you make a product of all these numbers, you will see that R is actually cancelled out. That is why if you know the product of 4 consecutive numbers of a GP, but you do not know the numbers, assume the numbers as A by R cube, comma A by R, comma AR, comma AR cube.
Yes.
Clear or not clear?
Yes.
Great. Now let's go to the next one. If there are 5 consecutive terms product are known to you, which are in GP, then how do you choose the numbers, dear students? So let me repeat. If you know the product of 5 consecutive numbers of a GP, but you do not know the numbers, what will be those numbers?
This will be A by R square, A by R, AR and AR square.
Fantastic. Fantastic answer, Sagnik. Appreciate. Dear Devansu, are you getting all the points properly?
Yes, sir. Understood.
Great. Fantastic. Appreciate. And always open up. No doubt about. Okay. In my class, always open up questions. No issue at all. We are all learning. We need to go for another 2 years and we have a rock solid preparation. Okay. Our understanding will be rock solid. All this learning, dear students, as a context, I can say it will be there for longer period of time in your career. So always make these fundamentals extremely rock solid. So what is that? As correctly said, A by R square, comma A by R, comma A, comma AR, comma AR square. Now if you make product of all these numbers, you will end up with only A, no R. Now what is my pattern, as you know, as you have attended the classes for last few months, that I always find a pattern. Finding the pattern helps you to solve problem in relatively lesser time. So what is the pattern here? Pattern is that if you have 2m plus 1 numbers in GP, how you will choose the numbers? And if you have 2m numbers in GP, how you will choose the numbers? Correct, dear students? So that I am going to
discuss now. So in general, if you have 2m plus numbers in GP, the way you can choose these numbers are something like this. Okay, as you see in front of your screen, it is a by r power m, then a by r power m minus 1, then a by r power m minus 2. In that way, it goes to a by r, comma a, comma ar, comma ar star, up to a r to the power m is the last term. Now, dear students, if you remember this thing, there is not a big deal to choose any number of odd terms, correct or not? Then you don't need to remember this thing, the previous three, correct or not?
Yes.
Previous three means fourth point and sixth point you don't need to remember, because fifth one is even one, that coming in the next formula. So that is why I always find a pattern. This pattern is important. Okay. Now the next one is that if you have 2m numbers of GP, you need to find. So it should be a by r to the power 2m minus 1, comma a by r to the power 2m minus 3, comma a by r to the power 2m minus 5. In that way it continues a by r cube, comma a by r, comma ar cube, up to a r to the power 2m minus 1. Correct, na, dear students?
Yes.
Clear or not clear?
Yes.
Okay. Then, as we are done with it, so then let's go to the next point. And next point, what we are going to discuss is about the if A1, A2, A3, all these numbers are in GP, then what will be if we multiply each term by a number, if we divide each term by a number, if I add or subtract a constant number, okay, then how, whether they will be also be in GP or not, that we are going to learn now. Correct or not, dear students? Okay, dear students, so I'm just going to place the relevant note in front of you. And just as a side discussion, all of you are keeping that notes properly now in your computer, right?
Yes.
Yeah. Please keep everything, okay? If you want to take printout, that is even better. Okay, and keep all these things in a channel file or something. You can make a book out of it also. And I'm also sharing our recorded class. So after looking into it, note if something is not clear, you can go to that particular video recording, that particular minute, and then you can get clarified. That is a very efficient way of revision. So what it is that if A1, A2, A3 are in GP, then KA1, KA2, KA3, they are also in GP. Correct, dear students? Okay. Then A by A1 by K, A2 by K, A3 by K, they are also in GP. Then if you add or subtract a constant number K, okay, they should also be in GP, that is GP, that is A1 plus minus K, A2, A1 plus minus, A2 plus minus K, it should be A2, A2 plus minus K, A3 plus minus K, they should also be in, they are not in GP. I repeat, if A1, A2, A3, they are in GP, then A1 plus minus K, A2 plus minus K, A3 plus minus K are not in GP. Okay, which is unlike with the AP, if you recall the relevant note. A1 power P, A2 power P, A3 power P are in GP for P belongs to R, and if we keep P equal to -1, we see that 1 by A1, 1 by A2, 1 by A3 are in GP. Got it, no?
Yes.
Then the fifth point, if all the terms A1, A2, A3, A4, all are, up to n terms or whatever are positive, then we can say that log of A1, log of A2, log of A3 are in AP. If A1, A2, A3 and so on are in GP and all the terms are positive, then the log of those terms are in AP. Why the numbers have to be positive, you know, dear students? Because as we know that log of a negative number is meaningless, is not defined. Correct, no? So that is why all these numbers has to be positive. And the converse is also true. That means if log of some numbers are in arithmetic progression, then those numbers are in geometric progression. Which means is that what is the converse is that if log of A1, log of A2, log of A3 dot are in arithmetic progression, then A1, A2, A3 dot there are should be in geometric progression subject to the condition that A1, A2, A3 all are positive. And also, as an analogy of the arithmetic progression, if you multiply the first term and the last term, second term and the last but one term, third term but last but two terms, their product should all be constant. That is A1 into AN, A2 into AN minus 1, A3 into AN minus 2, that is equal to A4 into AN minus 3 and so on. You understood, not, dear students?
Yes.
Okay. As we already know that if three numbers are in, geometric progression A, B and C, what we can say from here? We can say that the middle term B square is equal to A into C, correct or not? If they are in geometric progression, that we all know.
Yes.
So that's what we have written here in generic formula. A2 square should be A1 into A3, means left and right, product of immediate left and immediate right. That particular term square is equal to the product of the immediate left term into and the immediate right term. A3 square should be A2 into A4. It is A3 square, A2 into A4. A4 square is equal to A4, A2 and A4. A3 square should be A2 into A4. Are you getting my point? What I'm saying, dear students? If you find A1, A2, A3, A4, and so on, what I'm saying is that let me use a different color, is that A2 square, correct, no? That A2 square should be A1 and A3. Correct, no? That is their product. Got it?
Yes.
Clear or not clear?
Yes.
And so on. And there is a generic formula I have given after that. That AR is equal to square root of AR minus K into AR plus K. Correct or not? For all K belongs to N. So any doubt, please do let me know. Now, what we are going to do in the last topic before we conclude about the geometric progression is that, if there are two geometric progressions, suppose we have two GPs. The first one is that A1, A2, A3 up to continuing, and second one is that B1, B2, B3 and continuing. Then what we are going to learn is that what will be the behavior if we take both the consecutive terms of these two GPs and then analyze. So what does it mean? It means is that something like this, that if A1, A2, A3 and B1, A1, A2, A3 and continuation of that, definitely this is one GP, and B1, B2, B3 and continuation of that in another GP, then we can conclude these are the points. First point is that A1, B1, A2, B2, A3, B3 are in GP. Second one is that A1 by B1, A2 by B2, A3 by B3, and so on, they are also in GP. And the third one is that A1 plus minus B1, A2 plus minus B2, A3 plus minus B3, and so on are not in GP unless the common ratio of both the APs are same. It means that the common ratio, there's a spelling mistake. It means that if the common ratio of both the APs, A1, A2, A3, and B1, B2, B3 are same, we get A1 plus minus B1, A2 plus minus B. That means A1 plus B1, A2 plus B2, A3 plus B3 are in GP, and A1 minus B1, A2 minus B2, A3 minus B3, and so on, they are in GP. Got it, no?
Yes.
So, if their common ratio are not same, okay, A1 plus B1, A2 plus B2, A3 plus B3 are not in GP. And the other way, A1 minus B1, A2 minus B2, A3 minus B3, all these are not in GP. But if their common ratio is same, then A1 plus B1, A2 plus B2, A3 plus B3, all these are in GP. And A1 minus B1, A2 minus B2, A3 minus B3, all these are in GP. Correct, no, dear students?
Yes.
So with this, I conclude the discussion for geometric progression. In our next class, okay, which is on Monday, we'll discuss something interesting. And I just want to give you an initial idea about it is that it is called Arithmetico-Geometric Progression. Okay. So what is Arithmetico-Geometric Progression? Just I want to give you a fundamental idea before, so that you can think of throughout the day and tomorrow as well before we start our next class. Is that Arithmetico-Geometric Progression is something like this. Is that, just a minute. Let me read out rather than explaining, because I just want to give the fundamental idea. Let us consider following two progressions. First one is an AP, where the first term is A and the common difference is D. Quite common. When AP comes to our mind, what comes to our mind? Two things. What is the first term and what is the common difference?
Yeah.
And the second progression is a GP. And again, you remember, dear students, when GP comes to our mind, what comes? It comes, what is the first term and what is the common ratio?
Yeah.
So, the second one is a GP with first term B and common ratio R. Now, the arithmetico-geometric progression for these above mentioned progressions is a progression where each term is a product of the corresponding terms of the AP and that of the GP. That means what? The first term of the first progression is A, and the first term of the second progression is B, na? So that A to B is the first term of the new progression, that is called AGP, Arithmetico-Geometric Progression. Got it, na, dear students? We'll discuss in details in the next class. Then what is the second term of the first progression? That is the arithmetic progression, A plus D, na?
Yeah.
And what is the second term of the geometric progression? That is B into R, na? So then A plus D into BR, that is the second term. A into B is the first term, A plus B in the second term. So if there is any confusion, what I can say is that, what is that arithmetic progression? Arithmetic progression based on that statement with first term is A and common difference as D, it is A plus D, correct or not, dear students? Then A plus 2D, correct? Then A plus 3D, correct or not? And so on. It continues. Let me use a different color. Now, what is the GP? According to the statement, in the GP has the first term B and the common ratio is R. So then B into BR, na? B comma BR, not into, sorry. First term of the GP is B, second term of the GP is BR, third term of the GP is BR square, correct or not?
Yeah.
Fourth term of the GP is BR cube, and so on. So then what we are saying is that what is arithmetico-geometric progression, AGP, is that take these two first term of these two one, product them, and then write it here, A into B. That is the first term of that AGP. Then again the product of the second term of the arithmetic progression and second term of the geometric progression. Then what you are going to get? A plus D into BR, no?
Yes.
That is the second term of that AGP. Then you take the third term of the arithmetic progression and third term of the geometric progression. Then what you are going to get? A plus 2D into BR square, no, dear students? And then take the third term of that arithmetic progression and the third term of the geometric progression. What we are going to get is that A plus 3D into BR cube, and so on. That is called AGP, Arithmetico-Geometric Progression. Let me tell you, dear students, this is not at all required for your physics numerical. At least I have not come across any problem in physics numerical where this concept is applied. So we can have a very light discussion on that, okay? But when we will discuss about the sequence and series for the JEE main and JEE advanced, then we'll come with this thing in very, very details with lot of. Anyway, with this, I just wanted to give you that idea. If someone of you have interest, you can have a look into the online video lectures as available in the platform to have more idea about this thing. And with this, I would like to conclude the class for today, dear students, unless you have any specific statement or comments for me.
Yes.
Okay, so I will give you a few assignments now before concluding finally, is that I'm going to share another screen with you. And if you recall, the last in the last class, you did till 5, na? DPP 5, correct, dear students? Hello?
Yes.
Can someone please confirm? Till DPP 5 we have done, na? Yes. So, so now you go to the right online examination, start with sequence. So then you go for the 6, 7, 8, 9, 10. Can I request you to do all these 10, 6 to 10?
Okay.
Because tomorrow is Sunday, na? Tomorrow you have time, correct? Correct, this kind of questions, and we'll discuss after that what are the doubts you have before you go for arithmetico-geometric progression. So my humble suggestion to you is, dear students, from 6, set 6 till set 10, okay, please submit it. All of your DPPs are, once you attach and give it to us, it is all in our record. We will all evaluate it, but it will take time, as I said earlier, but we will all evaluate. But your learning will never get hampered because of that. It is our promise. Because if we keep all these things in a very disciplined manner, the preparation eventually become very rock solid. Eventually. Okay, dear students. So with this note, I would like to conclude the class finally for today. And see you on Monday at 9 o'clock in the morning. Thank you very much.